Hello, we will discuss the following linear differential equation. X prime of t equals minus t over 1 minus t square product with x of t plus t plus arc sine of t. So we easily remark that by denoting this term with a of t and this term with b of t, this is a linear differential equation. So the easiest method to solve it is to calculate the integrand factor. So we must compute the exponential of minus the integral of a of t with respect to t, which is the exponential of the integral of t over 1 minus t square with respect to t. But we remark that the derivative of 1 minus t square is minus 2t. So the previous term equals the exponential of minus 1 over 2, the integral of minus 2t over 1 minus t square with respect to t, and this is the exponential of minus 1 over 2 of the logarithm of 1 minus t square. And of course, this equals 1 over the square root of 1 minus t square. So we have computed the integrand factor, and we multiply the equation by this term, and we obtain that x prime product with 1 over the square root of 1 minus t square plus t over 1 minus t square product with 1 over the square root of 1 minus t square product with x of t equal t over this square root plus arc sine of t product with the integrand factor. Now we observe that these two terms equal exactly the derivative of the product between x and the integrand factor. So the relation from the right hand side is the same. By integrating this term, we obtain that x over the square root of 1 minus t square equals the integral of this term equals exactly minus square root of 1 minus t square, and we observe that the derivative of the arc sine of t is exactly this function. So by integrating it, we obtain the square of the arc sine of t over 2 plus a constant, a real constant. So the solution of this equation is x of t and c equals minus 1 minus t square plus the square root of 1 minus t square over 2 product with arc sine square of t plus c product with 1 minus t square.